So, I'm still confused. What was he talking about? I saw some numbers. Is there more coffee? Do we paint or don't we paint? Well, let me show you quickly a study that, that we did, our crack team here, of can we figure out how we're going to, whether we should paint wounds or not. Because in Texas, Dave Apple, the guy with the hat, well, the guy with the, I don't know, it's not a cowboy hat, but he's not from Texas originally. His recommendations were to prune, and that was the recommendations we gave in the state, or to paint pruning cuts. Those were the recommendations we were giving in the state, and I didn't want to disagree, but this was a great opportunity because it's not often that you can find trees that you can infect with oak wilt on someone's property, and they say it's okay. Come on out, you can do this study, infect all my trees with oak wilt, and let's see what happens. This was an area where oak wilt was coming in, so the trees were goners anyway. So we had to work quickly to make this happen, and our study didn't go too long before the oak wilt had swept into the area, but it was a rare opportunity. We've been looking for a place like this for 20 years, so expect research paper number 2 to follow up with this to be 20 years from now, if I'm still alive, because it may be that long before we find another one. So what we did, we made some flush cuts. We made some flush cuts that we painted. We made some flush cuts we didn't paint. Not that we're advocating flush cuts, but that we still see them. And then we had some what we called Shigo cuts, but natural target pruning outside the branch collar, proper pruning cuts that were unpainted as well. And then, of course, we had some positive and negative controls. When we looked at these this would be our true branch, and somewhere in there there's a branch collar. Gets pretty hard to find, but we would end up cutting just outside the branch collar to make sure. That's one of the reasons I was there, because we had 2 board-certified master arborists there. We weren't board-certified at the time of this study, but to make sure that all the pruning cuts were as perfect as you can possibly get them out in the field. And so we were trying to ensure that. Then what we did was we took spores of Ceratocystis, it's the fungus that causes oak wilt, and we put spores onto the pruning cuts. Now this one is, we had positive and negative controls to make sure that our spores were viable. And so we would make wounds into the trunk, and we had the positive ones where we added spores to those trees, and we wanted to make sure that those trees actually got infected so we knew our spores were active. And then we had a negative control where we wounded the trees and just put water on there, just to make sure that the trees didn't die because of something else. So we had positive and negative controls, and then we had these other tests that were involved. And so we made, this took forever, and I'll explain why in a minute, looking for true branches and finding the right trees and making sure they're separated from each other so that the fungus doesn't go down the roots of one tree and up another tree and really mess things up. And then got up there and made our pruning cuts, and then put spores on the pruning cuts, or we spray painted it with paint, let the paint dry a little bit, and then we put the spores on the outside, trying to mimic beetles coming in, although we put a lot more spores probably than a beetle would have on them. Now this is a little difficult to see. These are out of the Journal of Arboriculture, or as my friends in Massachusetts say, arboriculture. And so they're black and white and a little bit difficult to see. So let me kind of walk you through this, and if you're a distance away as well. Basically, we look at number of infected trees, and then we look at this number over time to see how quickly they became infected. And so within just a few weeks, we see, just in a couple of weeks, we see our positive controls, the ones that we wounded the trunk and put spores on. We see that in the number of trees becoming infected, looking at symptoms, really went up fast. We also look, the line right below that is practically as fast, or we see the symptom development practically the same with the flush cuts. It gets a little more interesting when we look at painted cuts and Shigo cuts, and then the bottom line is our negative control, right? We would expect, once we saw a tree become infected in the negative control, we kind of shut things down because now we're afraid that the fungus is coming in from other areas. If we just look at this on a table, we got, out of the positive controls, we got 70%, 7 out of 10 trees were infected, showing that our spores were viable. if we look at it, and if you look at these A, B, and C, anything that has an A, those are all similar, statistically similar. Anything that all have B's are all statistically similar within themselves, and C's. So positive controls A, flush cut unpainted is A, so it is not statistically different than our positive control, which we would expect, right? But when we get to the Shigo cut, we had 4 of our 10 trees that we treated were infected with oak wilt from making proper pruning cuts. Then we get down to the painted flush cuts, and we had only 2 of those. And actually, one of those, the paint slipped because it wasn't quite dry when we were painting it on there, and that probably got infected because the paint slipped. And so we showed that we can decrease, and this is on an improper pruning cut. This isn't on a Shigo cut. We can decrease the amount of infectious disease by painting the wound. The problem is it's still a little unclear, right? Because flush cut unpainted has a B, and it's the same as a Shigo cut that has a B. And they're not statistically different, either one of them, from the negative control, but the Shigo cut's not statistically different than the positive control either, right? So it's still not cut and dried, but there's a few things that you can take home from this, in that a proper pruning cut can get infected. And so that thought that, no, they protect themselves against infectious pathogens is wrong. Also, if we compare, let's leave the Shigo cut out, but let's just compare the flush cut unpainted to the flush cut painted. Although it's not statistically significant, we had a lot fewer infections with a painted wound than we did with an unpainted wound. So now I'm freaking some of you out because you're thinking, uh-oh, we don't have time to paint all those wounds. Well, remember, we're looking in this window of when nitty-doodle beetles fly, so you might be a little more careful if we're looking at oaks. And it's different, too, for Dutch elm disease. So if you're in an area for Dutch elm disease, I'm kind of giving you the Texas perspective, know when the elm beetles are flying, when your transmission is higher, and start thinking about that.